Okay, so let's quickly apply the concept that we've developed in the previous video to doing a cross product of two vectors. So we're given two vectors, we're going to find A cross B, and then we'll do one more thing. We'll show that this cross product is indeed parallel with A or B. We'll just show it for A, you can do it for B, and then you can go to the previous expression, which is all this, and show that this is indeed parallel with the vector A or B. Okay, it's a simple exercise. So let us use our definition. So A cross B, I like to remember this just using the determinants. It's much easier. I, J, and K, and then I write 3, 2, minus 1, and then I write 1, minus 3, 1. Okay, so we're gonna have to evaluate this, and it's very simple. Now, if you have forgotten how to evaluate your determinants, okay, there are a couple things that you can do. You basically take the first element. I'm going to show you the first element, and then you multiply it by the determinant of the column that's diagonal with it. Okay, you do the same thing with the next one. So for instance, to find the determinant, to find the term for j hat, okay, what I would do is I would just rewrite the numbers 3 and on the first column, and then the second column just once again. Okay, so to find j hat, you would take this and you would do the determinant of this, okay, the one diagonal with it, and then to find, say, the components of k hat, you would start with k hat and then find the determinant of the one inside the red brackets. Okay, so I hat ends up being equal to 2 minus 1 minus 3 1, okay, plus j hat times minus 1 3 1 1 plus k hat times 3 2 1 minus 3. Okay, this way I don't have to worry about signs and stuff like that. So now it's very simple. To find the determinant of this, you just do cross multiplication. Okay, so it is 2 times 1 minus 1 times minus 3 plus j times minus 1 times 1 minus 3 times 1 plus k times 3 times minus 3 minus 2 times 1. Okay, so this ends up becoming 2 times 1 minus 2 I hat minus 4 j hat and minus 11 k hat. Okay, so this gives us the vector A cross B. Now what we want to show is very quickly that A cross B is, ends up being parallel with the vector A or B. Okay, now perpendicular. So in order to do that, what we'll do is we'll take the dot product of A cross B with A. Okay, so we'll just do A dotted with A cross B. Okay, so the vector A was 3 2 minus 1, so it was 3 I hat plus 2 j hat minus k hat, and I'm going to dot this with minus 2 I hat minus 4 j hat minus 11 k hat. And when we dot this, okay, when you do the dot product, it's very simple. You simply multiply the components, so it becomes 3 times minus 2 plus 2 times minus 4 minus 1 times minus 11. Oh, something is not right. I just realized what I did. This should be minus 1. So this term is minus 1. My bad. Okay, so this is minus 1 here. Something seems wrong. Okay, so this is minus 1, so you get minus 3 minus 8 plus 11, which ends up being equal to 0. And so this tells you that the dot product of the cross with any of the individuals is always 0. So this is a general thing. Okay, so in general we can write this. In general, A dotted with A cross B is going to be equal to 0. Okay, or A or B dotted with A cross B is going to be equal to 0. Okay, and this all comes from the definition, so this shouldn't be a surprise at all, but it's always good to see that it actually works out correctly. And you can show this by even going through this expression. So I would recommend that you sit and you do this. It'll take you a couple minutes to actually do the entire algebra here, and then see that all the terms basically just simply cancel out. Alright, that's one